All right, so we're looking at the crash course for electron configuration. I will try and get how to write electron configuration and noble gas configuration, both within this same video. So let's go. On the periodic table, right, we're split into 4 blocks. 3 of them are right here. We have the S block, which is those first 2 columns. We have the D block, which is kind of the 10 columns in the middle where my transition metals are. And the P block, which is over on the right side of my periodic table, right, column 13 through 18. One exception is we have helium, which is up here and kind of technically in the P block, but it's part of the S block. So you can kind of imagine that this would go right over here if we could shift it around. All right, we have S, D, and P. The 4th block is the F block, and that is those bottom 2 rows that aren't really with the main section of the periodic table. We don't really deal with them a whole lot, so we're going to focus on S, D, and P. So let's look at writing electron configuration a little bit. How do I know what to write? And here are the 3 things we have to look for. So 1, the row number. The row number is going to tell us the big number that goes out in front, so the energy level that it's in. The block is going to tell us the suborbital, right? So if we look back here, this is row 1, so it has a big 1, and it's in the S block, so it's 1s. And then the last part is the element's placed within that block, and that tells us the small number, so how many electrons it has. So this is 1s1. This should be 1s2 because it's the second one in this 1s orbital. This would be 2s1 and 2s2 because it's the first one and the second one, again, in that 2s orbital. So that tells me the number where it falls. And that's really the basics of how to write electron configuration. So if we practice that, find magnesium's, just a box number, block and place within that block. So we're going to go to the periodic table. Hopefully most of it will fit. There we go. And so here's magnesium right here. If I look, it's in row 3. It's in that S block, and it's the 1, 2, the second one within that block. So it's the end point of its electron configuration would be 3s2. Then if I was writing out the full thing, I would have to write in everything that comes before that. So I would say, okay, 1s2, 2s2, 2p6, 3s2, and that gets me to magnesium, so that's where I would stop. The reason I don't say 1s1, 1s2, 2s1, 2s2, well, that would take a long time, right, if I wanted to write a long electron configuration. And we just say 1s2 and 2s2 and 2p6 because that tells us that that orbital is full, right? So if I could say 2p, 1, 2, 3, 4, 5, and 6, but that's kind of redundant. And again, if we just say 2p6, that tells me already that I have all the rest in there. So we just use the full orbitals when we can. So hopefully you remember, we did this in class. We took a look at this kind of a periodic table. We could actually write everything in if we wanted to. So here's my 1s, here's my 2s and my 2p, 3s, 3p, 4s, and then here's where things get a little bit weird. So in that d orbital, or that d block of my periodic table, we are 1 energy level behind where we are for the s and the p. So right, if I have 4s, that means I have 3d, 1 through 10. Then as soon as I'm back in the p block, I go back into 4p. Then I have 5s, 4d, 5p. So I'm always just 1 energy level behind. But let's say we were trying to, let's see what element it is. Gallium. All right, let's see if we were trying to write gallium's electron configuration. That means I need to write in everything that comes to here. Right, so I know I'm going to end with 4p1, but what comes before that? So I would say 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and I would end with 4p1 because that's where gallium is. So I just have to write in everything that comes before that, which is kind of a pain, right? But that's just writing electron configuration, so it can get pretty long. We could do the whole table if we wanted to. We want to be able to shortcut, right? We want to kind of cheat our way ahead. And that's where we're going to use the noble gas configuration. So the noble gas configuration just lets us skip ahead so that we don't have to write in necessarily every single step. So we'll do cobalt, which is right here, number 27. And if I wanted to write its noble gas configuration, that means I want to start at the noble gas that came right before it, right? I want to jump ahead as far as I can. I can't start with the noble gas that comes after cobalt because I can't write my electron configuration backwards. So trick is, if you just find your element, go up a row or up 1 and find the noble gas in that column, or row, that's what you want. So if I find cobalt right here and I go up and find the noble gas that's right there, I find argon, which means I'm going to start at argon. So now I don't have to write in anything up until this point. So I can just write AR, which I did right over here, right in the brackets. Now I'm going to start from there. So next I would have 4s2. And then cobalt is 1, 2, 3, 4, 5, 6, 7, 3d, 7. And you can see I wrote that over here. So this just saved me from having to write out 1s2, 2s2, 2p6. Now I could just start at 4s2. So to make it a little bit easier to write some of these heavier, bigger elements. And again, never forget that D block is 1 energy level behind, which is why it goes 4s2, 3d7. And that was the basics of the unit. That is electron configuration.